Alright, great. Because in the olden days, when I was at school, before we had calculators that could find our probabilities under curves, we used a thing called the cumulative normal distribution tables. And this shows the area under the curve between negative infinity and z1. So it goes from negative infinity z1. And this is what these tables look like. Your table in your textbook is on page 460. You need to know how to use it, but we believe that highly unlikely that you're going to get this in an exam, as every textbook's one is slightly different, and the QCAA hasn't published a standard one for everybody to use. But for this section of work, diagrams are absolutely essential, so you need to be drawing your standard normal distribution and showing your understanding of what the question's asking. So here what we're looking at is the probability of z being less than 2. Notice we're using z, so we're working with the standard normal distribution. I've drawn my little standard normal distributions already to save time. We're talking about less than 2, so I'm expecting a value of 2 here. Standard normal deviation, mean is 0. And I'm going to color in the area that I'm interested in. Now let's have a look at these tables. For z less than 2, this column here shows me my z value. So I'm going to go down to a value of 2. Okay, now it's 2.0, so I can see 2.00 is there, 0.9972. So I'm going to say from tables, the probability of z being less than 2 is equal to 0.9772. Let's try one more. Probability of z being less than 0.74. Now remember, that's going to be still to the right of my mean of 0, positive 0.74. And these aren't scale diagrams, they're just illustrative diagrams that show that you understand which part of the graph you are working with. Okay, so we go to the value of z of 0.7, but we need to go to 0.74, so we're going to go 0.7, 1, 2, 3, 4, and so 0.74 matches up over there, so it's 0.7703. So the probability of z being less than 0.74 equals 0.7703. If there are more decimal places, you'll see a bunch of columns called mean differences, and in your textbook they don't have any numbers at the top. But if, for instance, it was 0.743, you would be having 0.7703 plus 9. Alright. That's how to work with those mean differences. Alright, now we're going to use a calculator because we have calculators, so you know how to use the table. This was from tables. But even just with your calculator, you are expected to draw a diagram to show your understanding. So here we're talking z greater than 2.3741. It's quite a big number, so we've got our 2.3741 here. And it's greater than, so we are talking about that little area over there. So we're using our NCD. And again, we're going to have an upper, a lower, a sigma, and a mu. Standard normal distribution, standard deviation is 1, and my mean is 0. I'm going to go lower, upper, so let's try and keep it in the same order as the calculator has it. So it's our lower value now is 2.3741, and we're wanting to go all the way up to infinity, so 1 times 10 to the 99. I think the calculator goes to 9 times 10 to the 99 as well. Alright, so let's put that in. So our lower value now was 2.3741. Our upper value is 1 times 10 to the power of 99. Oops. Sigma was 1 and my mu was 0. And my probability is, oh, it's a small number. We're going to do it to 4 decimal places as we always do, so 0.0080. Alright, so look at the next one. We're now looking for the probability of z being less than negative 1.23. Now, negative 1.23 is going to be to the left of our mean, which is 0. So we're looking for a value of negative 1.23, and it's less than, it's that little piece over there. So using NCD on the graphics calculator, we have our lower, our upper, our sigma and our mu. Remember standard normals, so sigma is 1, mu is 0. Our lower now is going to be negative infinity, so negative 1 times 10 to the power of 99, and our upper is negative 1.23. And when we put that in our calculator, negative 1 times 10 to the 99, negative 1.23. Our probability is 0.1093. So our probability of z being less than 1.23 is 0.1093. Alright, my last example on this, we're wanting to do the probability of z falling between 1.5 and 2.32. 1.5 is positive, it's to the right of our mean, and so is 2.32, so I'm going to pick a value here and a value here, 1.5, 2.32, and I'm interested in this little area over there. So using NCD on my graphics calculator, my lower value, upper value, sigma and mu. So in this case, my lower value is 0.15, my upper value is 2.32, and I still have 1 and 0. And before we do that, let's just write our probability. And let's have a look on our calculator. Okay, and we're looking at 1.5, 2.32, 1 and 0, and that is 0.0566. Alright, hopefully that made some sense, and I'll see you in the next lesson.